If you place a magnetic compass near a bar magnet, you will notice a deflection of the needle. Do you know why the needle deflects? The needle is deflected due to the magnetic field created by the bar magnet. You will see a similar deflection in a compass placed near a live wire. Why? Is there a magnet inside the wire? No. Does the wire create a magnetic field? Let us explore. Hans Christian Oersted made the same observation in 1820. He found that the compass needle deflected when it was placed below or above a wire conducting current. He concluded that the current had produced a magnetic field similar to that around a bar magnet. There should be a relationship between electric current and magnetic field. His research later helped in designing various devices such as an electromagnet, an electric motor, a radio, and a TV. When an electric current passes through a conductor, it produces a magnetic field. He found that the direction of deflection depended on the direction of current. We have honored Oersted by giving his name to the unit of magnetic field. Different observations were made when the wire was placed above and below the magnetic needle. In each case, the deflections were observed in different directions when the direction of the current was reversed. The current flowing towards the north in a conductor placed over a magnetic needle deflects its north pole towards the west. Current flowing towards the south in a conductor placed over a magnetic needle deflects its north pole towards the east. Current flowing towards the north in a conductor placed below a magnetic needle deflects its north pole towards the east. Current flowing towards the south in a conductor placed below a magnetic needle deflects its north pole towards the west. The snow rule helps us to remember the direction of the magnetic field produced by an electric current. Snow, S and N, represent the direction of current, south to north. O represents the location of the current-carrying conductor over the magnetic needle. W represents the deflection of the magnetic needle towards the west. Ampere used an analogy of a swimmer to explain the deflection of the magnetic needle. It is called Ampere's swimming rule. He assumed a swimmer taking the place of the magnetic needle and his head as the north pole of the needle. Let's imagine a wire over the swimmer above the water level. Watch the deflection of the needle and the swimmer's head. When he swims north along the direction of the current, his head, representing the north pole of the magnetic needle, tilts towards his left hand. Ampere was able to explain all the four directions of deflection of the needle with the swimmer's analogy. Ampere's swimming rule is also referred to as the snow rule.